So thank you to Moshe. This was an amazing talk. The next speaker is Itai Grady. Itai is an experienced security researcher in Microsoft. Previously, Itai was a member of various research and development teams for 15 years in several companies, including Aurato, which was recently acquired by Microsoft, and he was also a 8200 intelligence unit 8200 graduate. Itai holds a degree in computer science. So before we start, we need to drink with Itai. Itai? So before we even start drinking with Itai, we need to get the computer working properly, which sometimes it happens. Okay, so now the computer is working, and let's do a drink with Itai. L'chaim. That's a good one.
Can you hear me?
Yes,
Yeah?
we can.
Thank you.
Can you hear in the back row?
Can you hear me? Great. Okay. Thank you for joining me at the talk in BSideds TLV. My name is Itai Grady. I'm a security researcher at Microsoft in the ATI group. Also, can't hear you? Can hear? No? Just a second. Maybe now? That's better? Yeah?
You good?
Yeah?
Oh, you're just welcome
Ah,
to this
no.
day. You're very kind, thank you.
Okay.
You had one.
I had one.
It's already in here.
First timer?
He was
First time?
too quick for you. Since we make a stop anyway, I just want to make an announcement, okay?
Okay.
I make small announcement. If anybody feels like they're gonna pass out from heat stroke, please take care of yourself. Don't do it. Go out, have a water. In fact, we have some water out here, and I'm gonna put them over there in that corner, water and glasses. So don't forget to stay safe and stay hydrated. We're not just cyber safe or something. Okay, I'll put it back. I'll put it back.
Can you hear me? Yeah. Okay. In this talk, I will show you how attackers can steal all your browser secret in a domain environment, and talk a little bit about how you can detect this attack. Sorry, my first time. I'm a little bit nervous. Okay, first I'll explain about the attack itself, the attacker's target and motivation. Then I will show you how exactly they will accomplish this attack by stealing your Chrome browser's stored password. And then we'll talk about a little the detection itself and show you a live demo. Well, attackers target cloud services. Most companies use enterprise cloud services such as Office 365, Salesforce, Zendesk, and others. Some attackers would just like to do negative PR, usually using social media. We've seen that this kind of action on the hacking team attack, where the attackers used Twitter to publish some negative PR on this company, this team. And of course, some attackers would just want your employees' personal data. You have their web accounts, banking, and etc. How would they accomplish this action? Credentials are the MO. Most modern browsers gives the users the options to store the site's passwords locally. You have it in Internet Explorer, you have it in Firefox, you have it in Chrome, of course, and even in Edge. So to put this attack in a context of an advanced attack, we usually divide the advanced attacks into 3 phases or 3 steps. The first step is the reconnaissance. In this step, the attackers gather as much information as they can on the target in order to compromise at least one machine in the domain. And from that machine, they're using lateral movement until they get domain admin credentials. And that will get us to the last step, where they access the assets of your company, of your domain. The attack that I'm talking about will focus on this step, okay? The attackers already got your domain admin credentials, and now they're taking as much data as they can from your domain. Okay, so how will the attackers take the Chrome browser and get all the passwords from it? First of all, we're all familiar with this save your password memo. Chrome, attackers know that Chrome's allowed the user to store the site passwords. They even have a managing window to manage all your passwords, to view them, and delete whatever you want. Now the attackers need to know where these passwords are located. There is a file named login data, which is under the app data folder for each user. And this login data file is actually an SQLite file format, which is a database. And it contains one main table, as you can see in this screenshot, which calls login. In this table, store the relevant URL that you store the password for, the username, and the password value. But as you can see here, I think so, this password value is a binary large object. It's a blob that the attackers need to find out how they can read it. So taking a look at the Chromium project, which is the open source of Chrome, attackers can see that Chrome uses data protection API, two functions, in order to protect and unprotect, which is encrypt and decrypt your site password. This API is basically in all Windows operating systems since Windows 2K, and is very common among many applications. As you can see here, if a user would like to see his stored password, he will need to enter his real password to sign in. But this pop-up is actually just a safety. I mean, if you are logged in to that machine and you just call the crypt unprotect data on that blob, you will see the password. This is just a safety for users. Don't leave your machine open. Main. So after looking at those two features, attackers know that they can decrypt any password on any machine. They only need to log in to that machine, use the user password, and use the DPAPI decrypt method to see the decrypted password. But that will require them to log in to any machine in your domain and get the actual password of the user, which is quite not really a good thing for the attackers themselves. So they need something more robust to do. I'm talking about Chrome, but as I mentioned earlier, Chrome is not the only browser that uses this data protection API. We have it in every other browser. Even Dropbox uses this data protection method to encrypt the decryption key for your folder. So you can even take that if you want. So the exact attack that I will show you here can be performed on any other application that uses DPAPI. Now that the attackers know that there is a binary large object that they want to decrypt, they would like to see a little bit more information about it. Thanks to Mimikatz, which is a post-exploitation tool written by Benjamin Delpy, they have a very good module that handles all the DPAPI attacking or exploits. One of them, you can use it to just describe the blob itself. The blob is actually a structure that contains many parameters to decrypt and encrypt this data. And one of the features, the parameters that are relevant to our attack is the GUID master key. The GUID master key is the reference ID, the ID for the master key that is being used to encrypt this data. Okay? Every binary every secret that you encrypt with DPAPI has a master key that is related to. This master key is the key that is being used to create a symmetric encryption key to encrypt and decrypt this data, and they will need to know which master key is being used for this secret. So taking this GUI with them, they will need to go to the folder which contains all the master keys of the user that they are attacking right now. And as you can see in this folder, which is also under the app data for users and under Windows local directory for system account, you can see the master key file itself with the same name, same GUID as the master key GUID. Easy. And if we'll take a look at the master key inside, we'll see 3 sections. Also, using Mimikatz, you have a description, describe a method for this file. You'll see that there is a general properties header, not really important, a master key section. This section is actually the master key itself, encrypted by your password, by a derivative function of your password. So this is something that the DPAPI uses for decrypting your password when you enter your credentials. And the last section that is relevant to us is the domain recovery key. This section we'll talk about later. It's really important for this attack. So keep it in mind. How exactly the DPAPI protects your master key? As I said earlier, the uses SHA-1 on your password, combine it with the security identifier of the user, which is publicly known, and random bytes that also known to the attackers. So since DPAPI is based on your password, in order to decrypt the master key, it must be aware of the password changes. I mean, if the user changes its password, it must be re-encrypted again with a new password in order to succeed in decryption of the blobs in your machine. So DPAPI is locally attached to the change password mechanism, and whenever the password is changed, the DPAPI re-encrypt your master key with the new password. But since we are talking about a domain environment, sometimes your password is being reset by administrator, sometimes you change it on a remote machine, sometimes you restore from backup, and in those cases, the DPAPI isn't aware of the password change. So it must have some method to recover itself. And no worries, as I mentioned earlier, we have the domain recovery key. The domain recovery key is actually the same master key that was encrypted by your password. Now it's encrypted by a secret DPAPI private key that is located on the domain controller. And DPAPI now needs to do the recovery process. How the recovery process actually occur? When the user enters his new credentials, the domain controller verifies authenticates the user because he knows the real, updated version of your password. And the user now, through DPAPI, authenticates to the domain controller, sends it the domain recovery key. The domain controller takes this key, decrypt it, and send you the master key again to the user, so the DPAPI can re-encrypt it with the new password. Okay, so now that attackers know about the recovery process, they would like to have some way to exploit it. And again, thanks to Mimikatz, they have a very simple way to do it. Mimikatz has a simple command that allows a domain admin with the domain admin credentials a way to get this private key on your local machine, LSA dump backup keys, as you can see here, and give it your domain fully qualified name, and you will have it on your machine. You can see here, this is the private key that is being used to encrypt the master key. Okay, so now that they have the private key in their own machine, they can take the master key that is relevant to the passwords, the encrypted password, and decrypt it also using Mimikatz, and have the relevant symmetric key to use to decrypt the password. Now, again, we have the SHA-1 key. We can use it also using Mimikatz on your blob that you extracted from the table, the login data table, and running it again will show you the exact password in the clear text. Here is Mimikatz. Really simple way, really cool way. The outcome. Now that the attackers have a simple way to decrypt all your DPAPI secrets on your domain, they can access any machine remotely, get the data to their computer, and decrypt them. I mean, they don't need the user password is no longer required. They just need the private key in their machine and decrypt it easily. Of course, the main thing here that they can send all this data to their homeland or home security environment and decrypt them, the data over there. It was fast. Talking about a little about the detection itself. Since the attackers must get to the DC and retrieve the private key from it, this request is going over the wire. So if you have a network analysis solution, you can see the exact request over the wire and detect this extraction of data. As you can see in the screenshot here, we can see which user did this request, from which computer, and if it was successful or not. This is all going over the wire, simple as that. Now I'll show you a short demo. Hopefully you'll see this. Okay, so right now I'm on a machine in your domain with the domain credentials, and I would like to steal some remote machine Google Chrome site passwords. Sorry, can you see it? Okay. Let's see who am I. I'm user 2. Located on client 1 PC, and since I know the network environment, I know that the 88 PC is some machine that is important to me. Let's see which users are located there. I have user 1 over there, and let's see if he has Google Chrome passwords. Yeah, okay, so let's copy the file login data. Sorry, copy. Okay, now we have the login data file. I'm not on the right directory, sorry, research. Let's run. We have the login data here on our machine. Okay, you're not authenticated in the same user. So let's. Sorry. Okay. So using Mimikatz to describe this blob. Sorry. As I said earlier, this login data is a SQL SQLite file format, so I will need to extract the site's password. So I'm using a simple application that I wrote to get it. Okay. You have it here, HTTP account. Let's rename it to something that will be much more clear to us. Gmail.com, Gmail bin. Okay, never mind. Okay. Mimikatz gave us the relevant GUID that we need. We want to have the master key with this GUID. Let's copy it. And look for it in the user's master key folder. Live demo. Okay, it's hidden file, so I will see everything. And as you can see here in the remote directory, the same GUID of the master key itself. So let's copy it. Let's copy, hidden. Okay. Let's take a look at the master key itself. Okay, so as you can see here, we have an option to recover this master key using the domain private key. Let's test it. Now I'll extract the private key from the domain controller itself. Pick up keys. Okay, we've successfully got this private key in our machine. You can see it here. Mimikatz also have a cache for the DPAPI, so the attackers or pen testers could easily use this module. As you can see here, we have the domain key cache. So if you have this GUID in your master key, it can be decrypted. And of course, we have it. So let's take a look again at the master key that we taken earlier. And now Mimikatz used its cached key to decrypt this master key. So now we have the SHA-1 encryption symmetric key. If we'll take a look again at the DPAPI cache, now we also have the master key cache inside. So whenever we will bring Mimikatz a blob that is encrypted with this master key, it will immediately decrypt it. So let's have a look again at the blob at the gmail.com. And as you can see here, the description, the decrypted data is Mimikatz. If you don't believe me, I can use Chrome to show you the password, but it is. Thank you. Any questions? Sorry.
So the hacker still needs to access every machine in order to retrieve this file from there?
Yeah, they need to access, you don't have to log in to the machine, interactive login, but you can remotely access the drives.
Okay, so if the attacker can access the machine,
Yeah.
can he dump the file locally, for example, by running a Chromium instance,
Dump which file?
or dump the password?
You can dump the passwords, but DPAPI uses your clear text and SHA-1 password on it. I mean,
But I mean, if Chrome has access to those passwords,
yeah,
can the attacker do the same by running Chrome locally?
yeah. You can enter the machine and use Chrome to decrypt it. Yeah, it's possible. But then you have to access and run Chrome in every machine. Or okay. Yes.
Follow-up question. Does it have to be Chrome? You can basically just call
Yeah.
the function and that's it, right?
You don't. It doesn't have to be Chrome. Any application that uses DPAPI, any secret that is encrypted using DPAPI in your domain can be extracted and decrypted back home. Okay.
Do we have any more questions?
Yeah. No. Okay.
Okay.
Thank you.